Number 6, we have a pretty long algebra problem here. The first step is just to combine our like terms. So we got to combine this 6 and this 4. We got to combine this 2x and this 3x. So I'll get you started. 6 and 4 makes 10. Bring down our minus 10x. Next step, we've got 2 and 3 x's make 5x minus 20. And then you're going to have to bring your x's to the same side. So we'll add 10x to both sides. And we're also going to, so that'll cancel this off. Now we need to cancel off this 20 over here. So we'll do plus 20 to both sides. And you'll have 30 equals 15x. So you got one more step here to tell me what x equals. Number 7, we're given this story. We're going to graph the hours of daylight per day for a year. Well, let's think. Here's our time and here's our hours. So time, let's say we start in the winter. I know that in the winter it gets dark earlier. So the daylight is probably a little bit lower. And then as the summer shows up, it's a little later. The daylight is higher. And then winter comes back. And so it should be something kind of like this, because this is like a solstice where we have the longest day of the year. You've heard of that. We have the shortest day of the year in the middle of the winter. It gets dark at 4 o'clock in this day in the winter. It gets dark at 9:30 on this day in the summer. So it should just have a peak. It should have one trough and one peak. It shouldn't really start at 0 because it should never get to 0. It should never be 0 hours of daylight. But and honestly, our graph probably should have been up a little bit higher because it doesn't shift too much. But this is like a 5-hour gap from the lowest to the highest. And I'm talking about it too much. I think you guys probably understand it. You've lived on this planet. You know it gets darker earlier in the winter and later in the summer. Number 8, is this a function? Are there any inputs with more than one output? Do we have any x's that have more than one y? Well, it looks like we have 4 different x's, so that's automatically going to be a function. That's going to be yes. We need to decide, is this linear or nonlinear? A couple things we could do. We could go to Desmos and we could plot these points. We could plot 10, 24, 20, 44. Okay, you can plot these points and see if it makes a straight line. Or we can look at our y change. This goes up by 20. This goes up by 20. This goes up by 20. Plus 20, plus 20 every time. Here is 10, up 10, up 10. This is always up 10. This is up 10. This is up 10. So this is a line. Its rate of change is the y change and the x change. Well, the y change was 20. The x change was 10. The y went up 20 every time, right? And then our initial value is where x equals 0, which is going to be this missing spot, this 0 right here. We go down by 10. So from here to here, we need to go down by 10 again. And so that looks like 44, 24. This will be down 20 to 4. So our rate of change is 20 over 10, in other words, 2. And our initial value, where it starts at 0, is 4. That was kind of a lot, I know. It's been a long time since we've done that, so I don't mind helping you out there. The y change over the x change, and we have initial value is where x is 0. So number 9, the initial value where x is 0 is at -1. We need to graph this. Our slope means we're going to go up 3 over 8, up 3 over 8. I'm not going to go any further than this. I think you can graph this line. And the last one, we need to write an equation for this one. What is our initial value? Our b, our starting value, looks like we start at 1. That's our y-intercept. And our slope, we go up 1, 2, up 2 over 1. In other words, 2. So we're going to write this in the form y equals mx plus b. Write this equation, but instead of m and b, use these two numbers.